Hey everybody, this is Mr. Wolf, and today we're going to be going over the Unit 6 test study guide. This is everything you'll need to know for the test, so if you are familiar with everything on this study guide, then you will be fine for the test. I wanted to do this because I haven't provided a study guide for the last couple of tests. I've just said use your notes, and I know that sometimes you may make a little bit of a mistake on your notes here and there, and it can make it hard to make sure you're studying everything precisely. So you guys should have already filled this out. And now we will go over the answers for it. Make sure that you have yours open and can correct any mistakes you may have made. Once again, if you know everything there is to know on this, then you'll be fine. I do want to say your test will be on the 23rd, if I believe so. Yes, the 23rd. That is a Tuesday. And the Monday, Tuesday, and Thursday, Friday groups combine that Monday. So you guys will all be there for the test unless you are fully virtual. So let's go through these, get some definitions down, answer some questions, and make sure you guys have everything you need for the test. So let's look at center point. The center point of a circle, of course, not what I'm going to do. The center point is the point equally distant distance from all other points on a circle. And you can give a more bland definition to say it's the one that's in the middle. It's the very center of the circle, the one that's in the middle, that dot right in the center, like the bullseye on a dartboard. So what about radius? The radius is the line segment connecting the center point to any point on a circle. So remember, there's a ton of radii. You can put them anywhere, but you're going to have a circle, and you have your center point, and it can be here, it can be there, it can be here, but whatever it is, wherever it is, it's going to be connecting that center point to the outside of the circle. What about the diameter? The line segment connecting two points on a circle that crosses through the center point. So any line you draw on a circle that connects 2 points on that circle and crosses through that center point is going to be your diameter. Similar to the radius, you can draw one here or here, here, as long as they share that point in the center. And that is very similar to our definition of chord. We could say any line segment connecting 2 points on a circle. So any line segment on the circle that connects 2 points, it does not have to go through the center point. The circumference, simply the distance around circle. I've used the example before, but if you were to take a circle and make a slice in it and flatten it out into a line and measure that line, you'd get your circumference. Of course, we have easier ways of finding that I'm sure you guys know, but we will cover a little bit on farther down if you cannot remember. What about arc? Arc is a portion of the circumference created by an angle within the circle. So we remember arcs. If you have a circle and there's an angle somewhere in the circle, like this inscribed angle here, this portion that I'm highlighting, coloring in there, will be your arc. Now we have minor arc and major arc. Minor arc is created by a central angle and measures less than 180 degrees. So the minor arc will be created by that central angle, which we have our center point, comes out like this, which we define here very soon, and our measurement will always be less than 180 degrees. That's our minor arc. The major arc is also created by a central angle, measures more than 180 degrees. So in a case we have an angle here, this would be our minor arc, and this portion around here, around this side, will be our major arc. Central angle, is an angle whose vertex lies on the circle with the other points lying on the circle. Oops, didn't mean to extend that far. So those pictures we just drew with the arcs, we'll redraw one here. Your center angle is going to have your center point, and then it's going to have the other 2 points of the angle somewhere on that circle. And that's your central angle. Remember, those form your major and minor arcs. An inscribed angle is an angle whose points all lie on the circle. So instead of having one on the center point or one somewhere within the circle, all 3 points of an inscribed angle are going to be on that circle somewhere. Kind of like that. Moving on, we got some more terms. A secant line is a line that crosses through a circle at exactly 2 points. This one's kind of like a chord. The chord connects 2 points on the circle, but the secant line comes through the circle like that, crossing at exactly 2 points. If it were to cross at only 1 point, you'd have what we call a tangent line. So a line that intersects the circle at exactly 1 point. So something like this. Pretend that's perfect. Something like that. And you'll always be able to identify those because they're kind of on the outside of the circle. It's almost like they don't really intersect. They just teeny tiny touch there on the outside. What about a secant angle? These are pretty simple. Secant angle is an angle created by 2 secant lines. Then we go on to tangent angle. If a secant angle is created by 2 secant lines, a tangent angle is an angle created by 2 tangent lines. Then what do you think it is going to be for tangent chord angle? We say it's an angle created by a tangent and a chord that intersect. We want to throw that in there too, and that goes for all of these. But of course, they didn't intersect; they wouldn't be an angle. So, sector, a sector. We did a big activity on sectors relating to pizza. So when you see sector, think of maybe a slice of pizza. A sector is the area bound by a central angle and its intercepted arc. So if we have something like this and a central angle, we'll pretend that's perfect. This area in here would be your sector. One giant piece, like the slice of a pizza. Inscribed is when a shape, figure, is fit tightly within another shape or figure. We looked at triangles and circles, circles and triangles. We had some polygons. So if we had a picture like that, we could say that this triangle is inscribed within that circle. What about circumscribed? A shape or figure is tightly we'll say tightly held around another shape or figure. So in this case, this picture we drew out to the side, we would say that that circle circumscribes or is circumscribed to the triangle, and that triangle is inscribed or is inscribed by the circle. So triangle, inscribed, circle, circumscribed. All right, now we get to some questions here that need answering. How do you find the diameter given the radius? Well, let's put this in terms of the radius. So if we have the radius, it's equal to the diameter divided by 2. Or we have the diameter that is equal to the radius times 2. And we kind of answered our next question here too. So if we have the radius and we need diameter, we can say either of those as well. You just plug in what you have. So your diameter is equal to your radius times 2, or your radius is equal to your diameter divided by 2. It's just best to know that the radius is half of the diameter. So if your radius is 4, your diameter is 8. If your diameter is 12, your radius is 6, that kind of thing. You just know that your radius is half the diameter. How do you find the circumference of a circle? We find the circumference of a circle by 2 times radius times pi. Or we can just say diameter times pi, because 2 times radius is our diameter. So either of those will work. How do you find the area of a circle? We would say radius times pi, or to write this a little bit prettier, we could just say radius squared times pi. So if our radius was 4, we could say 4 squared times pi is equal to our area. Or you could say 16 pi equals our area. Something like that. How do you find the area of a sector? Now this one has a few different parts, right? A few different parts. We had to say the area of a sector is equal to the measure of whatever arc we're dealing with. We'll just use AB divided by 360 times our area of the circle, which is radius squared times pi. So if you had, that would work in this instance if our arc was AB. So the measure of the arc divided by 360 times the area of our circle. How do you find arc measure given the central angle? They are equal. So if you have a central angle, something like this, and it is equal to 60 degrees, then you would know that this arc out here is also equal 60 degrees. So the central angle and its intercepted arc are equal in measure. how do you find the major arc given the minor arc? Well, you would take 360 degrees, because that's the entirety of the circle, and subtract the minor arc. And that would give us our major arc. It's very similar. How do you find the minor arc given the major arc? Well, it's the same kind of thing. 360 degrees, our whole circle, minus our major arc, going to be equal to our minor arc. And lastly, how do you find the inscribed angle measure given the intercepted arc measure? Let's look and see what this means. We have an inscribed angle, and we're given this arc measure out here. We'll say it's 120 degrees. Then we would know that the inscribed angle is 60 degrees. So what does that mean? We say the inscribed angle times 2 is equal to our intercepted arc, which means our intercepted arc divided by 2 equals our inscribed angle. Guys, if you know everything that we have covered in this video, then you will be fine on the test. You just have to know how to put these things to use given the context, and that's it. Most of the test, I wouldn't say most, but a large portion of the test is vocabulary, so focus on those vocabulary terms and you'll be fine. Make sure that you know these formulas and how to find these things, because you will be given problems that say, here's some information, find this. So study this. Copy these answers down onto yours, correct any ones that you got wrong when you went through it the first time, and study, study, study. This is a big test, guys. This is a big, important test, and I'm confident that you guys can all do good on it if you just take the time out of the day. I would say a couple hours here, a couple hours there, or maybe 30 minutes here, 30 minutes there. Just study this until you know it by heart, and you'll be fine. Thank you guys for doing so good this unit. If you need any help, any additional clarification on this kind of stuff, reach out to me or Mr. Rose. We'll get back with you as soon as possible. But make sure, if you have to watch this video over again, watch it over again, whatever it may be. I have faith that you can pass this test with a fantastic grade. Thanks for watching, guys.